You can put your presentation.
So, Spanish translation, this means move to a new window.
Yes, no problem.
Okay. So, where is it an extended? Okay, we're going to the right. Yes.
Sí. Pero lo grabo, no. Aquí, pero no se está compartiendo las cosas.
Okay.
I'm going to share by
You want to go to
the scenes, exactly. To share the screen. The second one. The
other window. This one.
You have to compartir this one. You can maybe just click this thing, maybe.
No, not the speaking.
This one. This one. Now close this window because in the plenary of this one.
This one?
This because it's my email and in the plenary of Jacob was the whole talk sounding like when I receive an email.
Okay. Do we need to like?
You have to click the other one.
This one?
Yes. Esa, me acuerdo hablado. Porque dejar de compartir no es.
Aquí no hay alguna otra pantalla.
Yeah. I need to get back to the screen.
Sorry.
Okay, this one?
Yes. Let's see what happens.
I think the click is sort of massively delayed right now. I promise I can place you.
Yes, I have it.
Sorry?
I need to talk a little bit about all the tasks.
Joder.
Dale aquí o lo que sea. Aquí. No, ahí a la eso.
¿Salir? Saliendo ahí de la llamada. Si hay un partido. No sé. No.
Okay, cool.
Porque está dejando de compartir ahí.
Oh, we're not sharing it. Okay.
Just,
Okay, so we're sharing all the desktop of the second screen. Okay.
Okay.
This is your song.
Vale, bueno, vamos a empezar la última plenaria
del Congreso, pero tengo que comentaros algo rápido, ¿vale? Porque nos acabamos de dar cuenta que juega el Betis. Es una experiencia, en Reina Mercedes es una experiencia...
A las 9, ¿no?
En Reina Mercedes es una experiencia astronómica, pues si no lo habéis vivido alguna vez, viene aquí millones y millones de personas. Entonces, ¿qué quiere decir eso para la logística del Congreso? Que los autobuses seguramente no lo vayáis a poder coger en la avenida de Reina Mercedes, tenéis que ir a la Palmera, ¿vale? Si alguno vas a ir, si los que vayáis a la cena, podéis ir andando bien de aquí, recomiendo que vayáis en taxi o cojáis el autobús en la Palmera, ¿vale? Está en la Plaza de España. No está muy lejos andando, pero bueno, si tenéis que pasarlos por el hotel o lo que sea, pues una vez que terminemos la plenaria, a las 9:15, por favor, lo que tengáis la cena, está en el sitio allí porque empieza todo. Así que nada.
Okay. For our English speakers, the translation, the one of the theme of the city, the first one, is playing at night, so maybe transport is a bit busy to go for the gala dinner. Okay, so good afternoon, everyone. It's a pleasure for me to present our last but not least plenary speaker of this Magnificent Congress. Hannah Frink is working right now at the Tidy Models team at POSIT in United Kingdom. She is PhD in statistical psychometrics in the University of Innsbruck, Austria. Did a postdoc in the College University of London, I guess. Okay. She's also a co-founder of the Our Lady organization. She's going to present us her plenary talk. What's new with tidy models? The floor is yours.
Obligatory mic check. Does that sound good? You can all hear me? Excellent. Well, thank you very much for the introduction, and thanks to the whole organizing team for having me. I'm delighted to be here. So yes, I do work on the Tiny Models team, and this is what I'm going to be talking about. I am a statistician by training. Now my title is software engineer, and I'm going to be walking that line between stats and machine learning and software engineering in this talk as well. And once you leave academia, you get the joy of presenting work that you haven't done. So not me, like I've done some of the work in this talk, but this is work by the Tidy Models team, and these are the faces of the team. So a lot of the work has been done by these three guys alongside me. This is Anil, this is Max, our fearless leader, and this is Simon. And you will see their names scattered throughout the talk. And before we jump into what is new with Tidy Models, I'm going to give us at least one slide to say what is Tidy Models. So it is a framework for statistical modeling and machine learning in R. And it is a framework that uses tidyverse principles. So the same ideas that have made the tidyverse relatively easy to learn and use, the same design ideas of how you, like, how functions should work, how you should be able to interact with them. All of these things that have made the tidyverse popular are the same design ideas that we try to apply to what I consider the heart of R, like modeling statistics. It's still sort of like the crafting base. And essentially, if you feel at home with the tidyverse, you should feel at home with tidy models as well. And when I got asked to talk about what is new, the usual interpretation of what is new is what is new and has been released to crowd. And I'm going to be talking about this, but I'm going to be talking about this more briefly than the second part here, which is what is new and in progress. So you're getting a little bit of work in progress. And part of the reason why I've decided to keep new and released a little bit more contained here is that most of these big releases of the year happen in the first half of the year, and then we talked about them in various places amongst them PositConf in August, and the talk videos from PositConf are now online since last week. So they're all on YouTube, including ours. We had a session with Tiny Models talks, but plenty of others, and I do believe that the quality of these talks at PositConf was really good. So if you're curious, I encourage you to go check out those videos, and I'll give you sort of like a, hello, this was the Tiny Model session spiel in a minute, so that you can decide whether that's of your interest or if you want to browse some other ones. So the thing that probably took longest out of these releases is adding support for time to event data to the entire framework. So time to event data, as the name suggests, has like two aspects of the time to and the event itself. And that event may or may not have happened yet when you're like, but I want to analyze stuff. If it hasn't happened yet, that's a censored observation. It's not a missing observation, it's incomplete, but you still want to make use of that data. So for the stats people in the room, this is pretty obvious that the methodology to deal with both an outcome that has two aspects and there's censoring involved, this methodology is survival analysis. For people who are not so familiar with this, the name survival analysis usually lets them think that's some stuff for like medical research and that's not applicable to me. And I've been trying to tell people this year in particular that it's time to event data and then methodology for that. And that event can be really a lot of things. Yes, it can be death in a medical context, but it can also be like time until your pet gets adopted in the shelter. So pretty broad applications. We've wired up support for it throughout the framework with its own mode, censored regression. And I got to talk about sort of the general why and what in more of an introductory talk on the data and the models. And then Max did a follow-up talk right after me talking about how to measure predictive performance for these types of models. So if that is data you may encounter and you want to use tiny models, these are the two talks to check out. My colleague Simon talked about a very different topic. He talked about fair machine learning. And tiny models does include several metrics for fair machine learning. And there isn't like one silver bullet, one metric that answers all your questions, because there just isn't one. So we also did not try to implement one, but rather Simon and other colleagues at Posit spent almost a year, I think, sort of catching up on literature, on other existing implementations, and then deciding on what to implement tiny models. And they've chosen it carefully to have metrics that support you in your thinking about the problem, rather than presenting you a too easy and not real solution. And he does a really nice job in situating that research and questions in his talk on fair machine learning. And last but not least is Emil's work on making predictions happen in databases. So if you're working in a context where you deploy a model and you have loads of data in your database, it's nice to not have to pull that data into R to make a prediction and then write it back out, but that you can do it in your database already. And that is what the tidy predict package was doing, but it was doing it for parsnip models. So in like the easy case, if you have a linear model, you know your coefficients, you can write a SQL or other expression that multiplies your vector coefficients with your predictor values, and you get your prediction. And that can happen on a database. But that wasn't including any of the pre-processing. And Emil has gone through the work of trying to make this work for tiny models workflows, so the objects that include pre-processing and the fitted model The package is called Orbital. If you want to check it out, and the talk is also linked in the slides. My slides are online. I'm not sure if you can read it, but they're on my GitHub. You know, get my GitHub profile. It's just a trick. I'm sure you'll find it, but it's sort of the repro 2024-3 IIIRqueR. So that is what we've been working on earlier in the year that is released, that is out there, that has talk videos and blog posts and whatnot. If any of this catches your fancy, go check it out. And I'm going to very smoothly segue into the new and in progress. So things get a lot more less polished, let's put it that way. And the first thing I want to talk about in that round where we're actively working on things is the topic of post-processing. And I decided to slap like a subtitle on. That's what you do after you're done fitting your model. And you do it to your model predictions, not to your data. The reason usually being you're trying to squeeze a little bit more performance out of it, trying to make the predictions better after you figure out how to make the predictions. But let's look at an example. So I brought some delivery data. That's just how long it takes to get something delivered. Since I talked about censored data earlier, this is all uncensored. This is the actual time until the end. Just looking at the time now, we're keeping things easy in this example. So time to delivery is our response. We've got a couple of predictors. We're doing the usual tidy models thing where we split it in training and testing, and then we're also preparing something for tenfold cross-validation. And then we're going to pick a model, and I'm going to deliberately make the model really bad to show you why you might want to tweak your predictions. So this is a boosted tree with a glorious number of 3 trees. So you're not going to get something very performant, but you get a model. We're not doing any pre-processing on the predictors. We are just shoving it straight. So we're going to resample that model, put it on the tenfold cross-validation. We're going to get some metrics out of that, and we are going to save those predictions. And well, we have metrics, so we might as well look at them. And we get an R squared of like 0.8 something, which is not too terrible. But as always, you gotta remember what your metric is actually measuring. And R squared measures the correlation. It doesn't tell you how close your prediction is to your observed value. That is a different topic. It's calibration. And why not look at it at a plot? So this is done with the probably package. And you can see that for higher actual observed values, the model quite severely underpredicts them. This is not a good model. I mean, deliberately so, but like if you're trying your hardest to get a good model and that's your result, things are challenging. And one of the things that you can do with this is calibration, and that's what we're going to be doing. So generally, why would you want to do any of the post-processing? Usually the motivation is to get better predictions out of it, with sort of adding a second step, and calibration is another model on top of that. Or sometimes you simply want to better satisfy distributional limitations. You might have a range that your predictions can't be outside of, something simple. And currently, you can do that, nothing's keeping you from it. It is not necessarily the most convenient way. So you can just do straight up decline manipulations on it if you're just thresholding predicted probabilities into hard passes with something other than 0.5. Or you could use the probably package, which has calibration implemented in it for numeric data. That is all okay. But what we are now doing is integrating it into the workflows objects. So a workflow in tidy models is the thing that contains currently your pre-processing instructions and your model instructions. The idea being that putting them together makes it easy to cross-validate them together, and you're not sort of creating data leakage with pre-processing. And now we're adding post-processing to go into that object so that you can fit the whole, like, do fit resamples on the whole thing. And we have a new package on the block for that kind of stuff. Meet Taylor. So the Taylor package is the thing that that connects stuff in probably and dplyr, so to say, with the workflow. And if you think of recipes for pre-processing, think of Taylor for post-processing. That's sort of the mental model that we're borrowing from. And if you have one for recipes, you're a good bit of the way there for Taylor. So similarities and differences in that mental model. Recipes works on the training data because we do pre-processing. Taylor works on the model predictions because we're doing post-processing. But you both sort of initialize an object. For recipes, it's a recipe. For Taylor, it's a Taylor. And then you add more specifications to it, steps to do, recipe steps. And in Taylor, those steps equivalent are adjustments to do. And then you sort of have, no, I don't even need to scroll. There's nothing more, just dead space. And then you have like the part where you estimate something, often that's called fit, and then the part where you execute something, often called predict, and they are called fit and predict for Taylor. I assume you're somewhat familiar with recipes, so that is the corresponding parts to practice. And I think those are harder to learn than fit and predict. But that is a very brief intro to Taylor. And let's use it. Let's use it with a workflow. We need to call library Taylor. Nothing happens without it. But then we can make a Taylor object. We initialize it with call to Taylor, like we would with recipes and recipe, brackets open close. And then we're adding the additional instructions of what to do with our model predictions. In this case here, I'm adding an adjustment that is a numeric calibration. So those off the wall predictions, you're going to get calibrated here. And then we have this Taylor object, like we would have a recipes object. And like we would add a recipe to a workflow with the add recipe function, there is now also a add Taylor function. So hopefully all of your like intuitions that you build up for tagging models already are working, and you can be like, yeah, I'm mapping this knowledge to the new part. So we can add the Taylor here, and now we have a workflow that has instructions for pre-processing, for the model fit, and for post-processing. And then we can send that thing through fit resamples, like we did before. The only thing that's changed here is the object that goes into the work. We're still saving the predictions so that I can do the original plot. And you can see still not perfect, but we're getting closer to that diagonal line. Still struggling with predictions for like large observed values, but it's where we're getting close. So, success. I said this is work in progress, so let's talk about what it can do and what it can't do yet. So what is implemented in Taylor as options for post-processing is what we expect to be the most useful and commonly requested ones. So if you have something that you need a that's not on this list, I will show a slide where to give feedback, let us know. But we're hoping we're covering a lot of bases with this already. So you can calibrate probabilities. You can either pick a different threshold or use equivocal zones if you're turning your probabilities into hard class predictions. And for numeric outcomes, you can calibrate them or tweak the range. And we have implemented, well, Taylor itself. There's support for it in workflows so that you can say add Taylor. And as you've seen, fit resamples and tune works with this already. And then there's like this unassuming line of support by our sample for some resamples. That concerns calibration. So calibration essentially fits another model on your model predictions as an input and your true outcome as an outcome. And if you fit yet another model, you want fresh data, unseen data. Like you don't want to risk overfitting by just adding a model on top of a model on top of a model and sort of fine-tuning too much on your training data. So what happens underneath the hood is that we hold back some of your training data for calibration if you have told us in your workflow specification that that is what you want to be doing. And how we do that is implemented in our sample, and we have that for cross-validation and bootstrap samples, and there are some more to go, including temporal data sets. And yeah, sort of that is part of what's yet to come. And the other thing that we still need to wire up in this is that you can tune with all of tune and not just say fit resamples, but you could say tune grid on a workflow that has pre-processing model specification and post-processing info. And if you care about this topic and want to give us feedback, that is very welcome. The best place to do this is via issues on GitHub on the Taylor repository. So in the Tidy Models org on GitHub is the Taylor repository. Click on issues. Leave us your feedback there. Yeah, so that is one thing that is work in progress that is in the pipeline. It's not too far off, I would say. And we're just gonna like move a little further. The other topic that's sort of hooking in the Tidy Models section is support for sparsity in a better way than currently. What I call sparse tables. And sparse data in the wild would be something you encounter if you have categorical predictors with a lot of categories and you turn those into indicators, or you tokenize text, or you have a graph data set. You can easily end up with a lot of variables and then a lot of zeros in them. So like the information in your data is pretty sparse in that context. And people often shorten it down to like sparse data. So that's where the slogan or the name comes from. And having a lot of data with a lot of zeros and sort of like going from one column of a categorical variable to like multiple columns can sometimes be a challenge in two terms. One, memory allocation. Your data set's already big and then you can like turn one column into many. That's not always easy. And the other thing is speed, because you need to work with Zipper. And the way that this is typically addressed is through a different data representation. Different to what is a solid question. So the default is called a dense representation. We have a vector like this, and we store all of the 25 values. That's a dense representation. I don't need you to count the zeros, but you probably have spotted the non-zero values because there's only 2. So if we don't want to store all 25 of them, because these 2 are the things that really interest us, we can try to switch to a sparse representation. And we only need 5 values for that. So we need to remember how long that vector is. So that's 1 value for the 25. We need to say the locations for the non-zero values. That's another 2 here. And we need to say those non-zero values themselves. So another 2. Well, that's 5 versus a 25. And whether that's an interesting move depends on how sparse your data is. There isn't like, this is always better. I think we all know there's no free lunch, right? There is a little bit of a trade-off, but if you are in a situation where you do encounter a lot of zeros, this is interesting. And the big player in R for implementing stuff, this is called matrix package with a capital M that implements sparse matrices and sparse vectors in efficient matrix operations for this. So we're addressing both the memory concern and the speed. And you can make a sparse vector. I made the one that I just showed you with the 25 values and 2 non-zeros. And yeah, even a print method looks pretty sparse, right? And matrices are good sort of when you're really close to going to fit a model, when you actually have like a model matrix. And the efficient matrix operations are for that. But that's pretty late in the game. Usually when you have your data, you have it in a data frame for a good reason, because you have often different types of data, right? So there's a little bit of a hiccup in using the matrix package directly in the tidy models framework. So if you give us such a matrix to go fit the model, we can like take it and pass it on to the modeling function. We're not touching it, it's fine. That is what is there already. But we have a slight problem trying to stick sparsity into tibbles. And I feel like in these sort of things, it's always good to remember, like, what are you trying to do? What are you trying not to do? And why? And the best place to start is why. So let's pull back for a moment and like talk about what we would really like to have here. So for one, if you have something that is in a sparse data format, we would like to preserve that throughout the framework. If you run into something that can't handle sparse data, they will what's called materialize and like fall back to the dense representation in the new memory mode. We want to preserve it, and we want to preserve it across the framework. And the thing that carries data across tidy models is a tibble. So that's where my interest for putting a sparse vector into a tibble comes from. The other thing we would like to have is to be able to make use of sparsity where it makes sense. So maybe if you're turning your categorical variable into a lot of indicator variables, you want to make use of them and you want to make sparse indicator variables. So that's where we would like to be able to add sparsity. But note that this is sparsity on a predictor level, or in terms of like objects, we want actually sparse vectors, and we want them in a tibble. And the last one is kind of casual, like we want to make things easy. Sounds great, but it really is like a fundamental idea of all of tidy models. The idea always being not easy for easy's sake, but rather you're dealing with complex problems. we don't want you to spend all your energy and thinking capability on like the technical bits of handling sparsity. We want you to be able to rely on tidy models for that and keep your focus on the actual modeling. So that's why this matters. And we want you to not sit in, like as a small example, we don't want you to be like, oh, but I actually don't need all of the rows, and if I filter this, like, will it break sparsity if I take out some rows because now we need to change things? And you just want to be able to say dplyr, mutator, or dplyr, filter on the thing. Right? You do probably, we certainly do. So that is a long-winded way of saying why we really want sparse vectors in a tibble. Not all of them have to be sparse, but we want to be able to have some vectors to be sparse. And as you saw, unfortunately, we can't just straight up stick sparse vectors from the matrix capital M package into a tibble for technical reasons I'm not going to like dive into, but I'm going to be like, ta-da, welcome sparse vectors. So that is another moment of like, what are we doing? What are we not doing? So sparse vectors is not intended as a replacement for the matrix package. It is our way to have sparse vectors that we can stick into tibbles. And we're not aiming to implement any of like the efficient matrix operations that the matrix package has. So if that's what you're interested in, then go to the matrix package for matrix operations. That said, sparse vectors is its own package. And if that sounds interesting to you, you can go use it. It is, we will use it, or we are using it in tidy models, but it's its own thing, and you can use it in other contexts if that appeals to you. So it allows us to do that thing that I was after, put sparse vectors into tibbles. And because we want to be able to talk with the rest of the world, also it has fast conversion methods to go from a tibble with a sparse vector in it to formats of the capital M matrix package, so that you can then send that to like a model fitting function, for example. Okay, I said work in progress. I said some stuff's implemented, some stuff's not. So let's get to that part. Implemented already in recipes is that the start of everything in recipes, the recipe function itself, knows what to do with this and doesn't just smash your sparsity and materialize it because it's like me. So that will pass through. It will also pass through prep and bake. Parsnip's fitxy function also does not destroy your sparsity, neither does predict. And in workflows, fit and predict also leave it alone, which is really nice. But obviously, what's not happening? So there's currently, well, I could say a caveat, but really it is like the area where the work is at right now are the recipe steps. So when a step touches a sparse predictor, it may or may not be sparse afterwards. So for some steps, that's just inherent to what you're doing. Like if you're sticking a vector into a PCA, you're not getting something sparse back. And you will not in the future. But if you're doing sort of like the indicator variables, or other things where it might make sense to keep sparsity, the goal is to preserve that. And some of them work already and some of them don't. So whether or not the data set that you get out at the end of your recipe pre-processing is still sparse has the answer. It depends, and it depends on what kind of steps you're doing. And then there is one thing that some people want to do and some people are skeptical about, which is why I put a big maybe on this. So if you want to use the formula interface, which is lovely, which is a great thing about R, and in tidy models, that is sort of, we call fit. on a parsec model, or if you invoke that by using add formula as the preprocessor in your workflow, then you're down a code path that will eventually lead you to model.matrix or base R. And that one uses dense data. And unless we write something that replaces model.matrix, that will be the case. So maybe we will have this in special cases. It will, I'm pretty sure it will not be it will always work kind of situation because of the nature of things. But I don't want to send you off of the side like, that's not going to happen. This is very much work in progress. But we are pretty excited about this because of the possibilities that this opens up for sparsity in pre-processing. So far, sparsity is mainly relevant for model fitting, and now there's like more happening on the pre-processing side. So we don't quite know yet where that will lead us, but we're pretty excited to find out. This is the feedback side. If you have feedback on sparsity in general and sparse vectors in particular, put the issue with the sparse vectors repository. That is not under tidy models, that is under RLib. The only thing I recognize. Presume if you search it, you'll find it. If you have feedback on sparsity sort of in context, go to the corresponding repository. So if it's like sparsity pre-processing, go to our space. Leave us a note. We're keen to hear. And now we've had post-processing, sparse tables. And I brought you a third one because fleetings are fun, right? And that third one is better errors. Not quite as big and flashy as the other topics, but more like the bread and butter of things. And sometimes you notice. Usually when you run into an error, it's not the best moment in your life. And recipes used to be pretty tricky. So you write your beautiful recipe, you try to fit your workflow, you get an error, you're like, okay, fine, I know my debugging strategies, I'm going to bake that data set first, I'm going to prep it, I'm going to bake it, and like remove the complexity of the workflow. And then you try to prep it, and you still get an error. Hopefully the error tells you something useful. So here it says, column already contains new level. So new level is like your key, oh yeah, I did something with new levels. And you can look for that step. And I know that people have been devising a debugging strategy where they comment in and out steps to like narrow it down. That is a good strategy, but wouldn't it be lovely if this thing just told you which step the problem is at? And that is what it does now. And, you know, like it's not a new feature, although that one is so helpful, you could somewhat argue it's a new feature, but often the error messages are not the thing that you can like write a lovely blog post about. We do write about them, but they're sort of like slotted into things. And I've decided to put a little bit of a variation on the keynote topic spin usually. So I have given you a few an exciting work in progress. But I also want to talk about the other work that we do. And it doesn't always result in extremely helpful error changes that you can like easily show. So this is a little bit of a how we work kind of section of this talk. And we typically call this type of work upkeep. It is largely the same as maintenance work, but not in the sense of somebody else changes their package and it breaks yours and you have to update stuff. that falls into upkeep as well. But upkeep also is the idea that we make an effort to regularly touch our packages, and not, because we have quite a few of them, and sometimes you don't do new feature work on it for 2 years, and then you get a bug report, and you're like, oh, I need to fix stuff. You open up the code base and you're like, ooh, we are doing things differently now. And it's not because you wrote bad code in the past. It's just because the world around it has moved on. And so we try to touch things regularly. And if you're writing your own packages, you don't have to look after the amount of packages that we do. You just have to be busy and do a lot of different things. You also might not get to touch your package every week. So the idea here is to show you what kind of tools we use to both provide users with helpful errors and to do that in a way that lets us still stay on top of things, to not accumulate the biggest maintenance burden in all of this. So I hope that's an interesting variation on the new and flashly and work in progress. So what makes an error helpful? And I think you do need to tell your users what happened. That's like the basic. It'd be good to know where it happened. And the hard question is why did it happen? And you can't always answer that in an error message, but you can sometimes be pointing them in the right direction. And sometimes you can also point them even further in the right direction by giving them hints to further places to look at things, or if it's a clearly typical mistake, you can be like, did you mean to do this instead? With moderation, don't be quippy, but sometimes that's helpful. So how do we do that kind of stuff? And I do hope you can read some code, right? Otherwise, I'm going to be reading out a lot of those. How's that working? Sort of? Okay, cool. Excellent. So I've brought a small function. I'm going to stand here so I can see this a bit better. It has nothing to do with tidy models. This is just not overload your brain with statistics. This is just about when it's time to water your plant. And that plant should be a string. Otherwise, it's going to error. Because all you do later is paste a string into a text and be like, oh, good. That plant doesn't need to be watered yet. But you don't want to say that plant. You want to say the specific one. But if you use that with a number, it's going to error. So plant must be a string. Okay, fair. The thing we have done so far to try to be helpful is put backticks on this here. Just to indicate that that's the argument. And that's the thing where you might want to pull up the documentation, what was that? Why does this not work? So that's very minimal stuff, but it helps. But as a maintainer, you have to remember to put those backticks there, and you have to remember that backticks are the thing how you format arguments. I've highlighted this, okay? Or you switch from an rlang abort statement, which is our version of basically our stop. That's the thing that throws an error. You can switch to CLI abort. And CLI does a lot of things. Here, it just does the styling. Not that exciting, especially if it's just a few backticks. But the point being, these are all small changes and they add up. I'm going to show a few more things about what CLI can do. But amongst other things, it can do a lot of different styling parts. And you just have to remember to put the right tag, which is often easier than to remember to consistently apply formatting yourself. To the user, this doesn't change. And that's a good thing. This just makes your own life easier. And I said I'd show some more things that CLI can do. I'm going to change that message that you get if you succeed. What we do in here is applicable to like CLI functions across the board, including CLI. So we have like, we're basically doing string interpolation. We have our string and then we inject the value of plant in there. And then we print it out and we are being good citizens and we're putting a new line at the end and we have to remember to write that new line. If you want to do the same with CLI, you just use CLI text and you do string interpolation by putting curly brackets and evaluate stuff. So that's kind of like a mashup of the glue package and the Erlang board. And then it does an additional thing because nothing keeps you from putting several plots in. So it'd be nice if that sentence worked for all of them. So what this does is like, it's clever enough to see that plant may have multiple values. And if it has only one, it uses the first option here. Do I have this? Okay, cool. It says that plant doesn't have to be watered. Like here, all good. The Monstera doesn't have to be watered yet. But if you put in a vector of plants, it says all good. The Monstera and that other plant don't need to be watered yet. This is not groundbreaking. Not like that. But it's pretty darn convenient. Like you get to offer your users nice English sentences without doing a whole if-else dance of figuring out whether it's plural or not and how that pluralization should go and where to paste in all of that jazz. And that's pretty nice if you would do this a lot of times, or if you only do it very sporadically. Because if you're not touching that often, you might have a little trouble. And that makes sense. So I feel like that is a nice thing for someone who maintains a package. And the result is a nice thing for someone who uses the package. Okay. I said there's a bunch more formatting options. The ones I use most regularly are sort of the catch-all. Format this as code. Format this as a class. And the last one is like a function. And if you just give it the function name, it will add brackets and will add the backticks. But what's really cool is what happens if you give it package name, : function name. Because then it creates, depending on like which IDE you're in, hyperlinks to the documentation pages. So you get an error message and it might say, look at this function, and then you can just click and get there. And then you can do like more jazz with links. So in Parsnip, we sometimes want people to look up the model specification, and that object is called model_spec, and that's okay, but sometimes we just want to say model specification. So the error message makes it so that if you click on model specification, you land there. And if you're in quarter slides, you're not in an interactive IDE. You don't get hyperlinks there, but you get to see how it looks if you're doing this, say, on a console, because that's where you run your R. And then it will sort of add the code that you could run to get to the help page. So it doesn't leave you in limbo if you don't have hyperlinks in your thing. But if you can have them, it will give you hyperlinks. So that's a little bit of like CLI niceness for the error message. The other thing that we're changing throughout the framework is to pay more attention to the kind of call info that you get when you produce an error, because that tells you where. And we have a bunch of functions that are internal. They're not actually meant to be user-facing. We have others, and then they call them. But what happens if you call plant care, which then in turn calls time to water, is if it throws an error, it will show error in time to water. Here, that sort of means something. but not all internal functions are named with the care that you do for user-facing functions. Fact of life, I would say. So to then expose your user to your internals in a moment where they are under great stress because they produced an error is maybe not the moment you want to do this. So what we would like here is to, for that thing, if you call PlantCare and it throws an error, for it to say PlantCare and not be like, tend to use it to be like, sorry, where's that coming from? If they want to go jump into a debugger, they still can. You're not like keeping things on it. But a casual user might get confused with this, and you can hide it pretty easily. So CLI abort has a call argument. And the nifty thing that happens here is that in the function definition, we say capture the calling environment and then pass that to CLI abort. So when you execute PlantCare and then you execute time to water is, where am I being called? Oh, I'm being called in the context of PlantCare. Capture that, and then when you error, spit that one out. So now you have the user-facing function as the function that throws the error. Also not the flashiest new thing, but helpful. And like you will see these changes getting rolled out across time. We sure do have a lot of error code, so it is taking us a while. We've been at it for a good bit, but I think we're at least halfway there. So once all of these changes hit pad, you will get nice errors in this regard as well. And I am like at time. Am I not? Should we leave? So well, okay. There's like 2 more things to show you. Let's do them, right? You still awake? You're doing better with this time than me, I'm sure. Okay. So we were like, what happened? Where did it happen? And now we get into the meaty question of why. And this is sort of like back to the start where we're moving the PlantCare. We're just like bare bones, time to water. And it tells us it must be a string. And it's good, it tells us what it must be. But sometimes they're like, okay, fine, I get that part, but what was it? If it wasn't a string, I thought it would be a string. And that's a really easy way to add that information. It doesn't always save a user from having to go debug stuff more severely, but it's a nice starting point to get to something like plant must be a string, not a number. You're like, where did the number come from? Oh, okay, well, in this case, you can see that, but sometimes you're like, hold on, why is it that? And the way to do this in CLI is to stick plant in curly brackets and then have it in the sort of tag of object type friendly. And what that thing does is evaluate what object type plant is and then spit out a friendly English language description of that. So 5 turns into a number. And it works for like a multitude of objects pretty broadly. My test to see how far I can stretch it is to take ours, basically hello world example of a linear model. So yes, I put a linear model in the time to water function. It does tell me it must be a string, not an LM object. Good. So that's pretty helpful. And it doesn't take much effort to add that. So that's a little bit of nudging you, giving your user a first step on the path of like, why did it happen? That doesn't always solve your problems, but it's a relatively cheap and easy way to get people in the right direction. Sometimes you want to be more explicit, you have more stuff to say about how to fix a particular problem. And you want to put that help into the error message. But then, like, if you have a lot to say, you run the risk of producing like an error message that's long, and then nobody will read your helpful text. It's just a long text. But if you break it up a little bit and give people 3 bullet points, your chances are much better of reaching them. So what CLI and RLang errors underneath can do is give you bulleted errors. And that happens when you just don't, not just give it a string, but rather a vector. And then I say I equals, and that's sort of like an informational bullet point down here. It still says error in that function, and then the error message, which I have changed to switch things up at the last minute. And then it has like I, and it gives another hint. And that is usually helpful if you want to point people to like other functions. You can use the linking that I showed earlier. So where we do this for real and not just like picture pods, you will see when you need to water them, is like a situation where this is helpful is if you're expecting data in a particular format, say spatial data, Marco, and you can leave a hint of saying, right, look at the help page of this particular function to convert your object from a regular data frame to like an SF object or something like this. So we sometimes point to like other functions in the tidy models ecosystem or framework for this. Time to wrap it up. So I think errors are most helpful if they tell you what happened. That's the error message itself, and CLI has a bunch of options for you to add styling and string interpolation and pluralization and links and all of that jazz. It can help you be more direct in like where an error happened. You don't always have to like make it just a user-facing one. If your function does a whole lot of different things and you think it is helpful to know where, like we're not gonna say always error in tune rig, because that's a non-server function, and sometimes it might be helpful to know if that was like a pre-processing error or a model fitting error or something else. But it gives you the control to say like the level of abstraction that you're going to give here and which call is going to show up. The dreaded question of like, why did this happen? You can help people by not only telling them what was supposed to happen, but also what actually did happen. So that was in part the object type friendly. And if you have any helpful hints to tell people, you can add that on in like informational messages or other types. There's a bit more styling and what the bullet points look like. But essentially, break up your text, add some more context if you think it will be helpful. And to like get into my last slide, what if you want to know the news and I'm not there to talk at you for an hour? Announcements about new things, go onto the Tidyverse blog at tidyverse.org/blog. And then our home on the web is tidymodels.org, where we have a collection of articles that are more in-depth texts about various topics, statistics and modeling, what you might want to know about that in the context of tidy models. So, and with that, thank you for your attention.
So here, question, comments, or request?
Thank you very much. I love it. How is it combining languages and having translations in your CLI errors and messages?
Combining translations.
Yeah, I mean, what happens if you want to have your message in both English or Spanish, depending on the language?
That is an excellent question. And I know that there's a working group that tries to translate base R errors for like you install R in a different language. I am blank on like how that translates to CLI. I'm not sure where it does, but there's work being done on this very interesting area, and like maybe they haven't converged yet, but yeah.
So I call another question. Okay, I have. It's more a personal question than other thing that in technical, because I'm not a huge expert in this area. But it's more like how your team and in general people that work in this kind of huge package that there are thousands of people using for an enterprise or for academy or for whatever, how you will manage to help or take into account all requests, take decisions, or what are you going to do now, what are you going to do now, or how you move.
The real meta question, how do you work?
No,
Okay, so I'm in a lovely situation. Well, lovely on the left, but our work is public. Like you're not sitting in our teams, but the vast majority of what we do is visible on the web in the GitHub repositories. And there will be like explanations about why we made a certain decision. And the web also has documentation for us that you can take and apply in your own workings. So we have documentation online about sort of the saga, how we write it better. There is a document on how we do code review, how we discuss changes in the code. There's a repository that has documentation on like the bigger decisions, why we're going one direction with an implementation and not another. That one's called a tidy up. It's sort of like a similar idea to like a pet for Python, where you say, this is our problem. These are potential solutions. We've gone with this one for this reason. This other idea that sounds really good did not work because of, and sort of like, sometimes these things are written up after the fact, but usually those are written up before you make a decision to gather feedback. So if you're interested in the, like, how we work, look for this kind of documentation. It is really like the guideline of how we do our work. And we make it public in case it is helpful for other people doing their own work on similar or a different scale. But yeah, I enjoy that part. So.
Okay, so if there is no other question.
Yes.
Oh, sorry, I didn't see you. But Paul.
I have a questionable or a difficult question for you. Do you want? Okay. What do you think about the GPL license and the saying of that way of your company about that?
GPL licenses?
GPL license, yes.
So I know that some packages will license GPL. By now, tidyverse packages have been relicensed to the more permissive MIT license with the consent of all the people who contributed and had like a say in the whole story, for the reason of them being more permissive. Like, Posit does not make any direct money off of our open source packages that we provide. And I am not a lawyer, disclaimer that goes with it. The conscious choice was to go with the MIT license. like a GPL license, in my understanding is that you can use it, but if you use it, you have to like keep it under that license. And I think that makes sense in many situations. It wasn't the choice for this. Being more permissive with the MIT license for the tiny models packages. Does that help?
Yes.
Okay.
Okay, well, another question.
Yeah, like, well, I'm a complete ignorant in machine learning. It's quite too older because you hear that all the ML is done in Python, right? I'm curious, like, can you do the same thing by models that can take to production is as performant as, famous libraries in Python?
There is not full feature parity. You can do certain things in Python you can't do in R, and there are certain things in R you can't do in Python, coming sort of from the background of more of a computer science approach to modeling and more of a statistic approach to modeling. Like something that is bread and butter, just statisticians being able to specify interactions is surprisingly hard in Python, whereas other things like text processing has like a little bit more functionality available in Python. So what is interesting for your problem really depends on your problem. I very much think you can put R into production. People do it. There's but that also depends a little bit on your definition of production. It depends on what your context is. If all the people around you are computer scientists or general software engineers, and they don't know what to do with R, that is hard, but not because of how R is, but because of the context. And if they are no, please use a general purpose language like Python, then that's a large incentive to do that. But it's nothing about R per se that keeps you from it. And in the spirit of sharing work in progress, the topic of R in production is sort of one of Hadley Wickham's focuses at the moment. He's given some keynotes on it, and he's working on a book called R in Production. And several of us are working on some more technical bits along the way because everything's there and sometimes it might not be as smooth as it could be. So we're trying to make that experience a little nicer, a little easier. But it's by no means impossible. So there will be technical infrastructure and social infrastructure and how to talk about this with improved packages and a book that Hadley's writing. So if you look for Hadley's work, R in production is the keyword. Can follow along on that project too.
Well, in case no other question, right? Yeah. So say thanks to.
I feel weird standing up for you. So thank you very much.
Thanks to you, Hannah. See you here. Okay. Don't worry, I'll.
Okay, well, I mean, there's nothing. It's not good. It's just get that slides.